Hello there. We are ready for problem number 4 on page 76. There are 5 rides at a theme park, 2 of which are roller coasters. So I'm going to go ahead and draw a sketch of this problem. I have a roller coaster, then something else. I'm going to call that other, and other. So there are 5 rides at a theme park, 2 of which are roller coasters. Maria wants to ride each ride once. She chooses a roller coaster for her first ride, then randomly chooses the second ride. What is the probability that the second ride is a roller coaster? Okay, we know that we want the first ride to be a roller coaster. That is for sure. Well, how many rides are there? There are 5. And of those 5, how many roller coasters can she choose from? There are 2. 2 roller coasters. And I'm just going to say, I'm going to take this one out. We'll just pretend that that's the one she chose. So here she comes for her second ride. And this time they want to know the probability that she chooses a roller coaster. Well, now there are only 4 rides left, and only one of those 4 is a coaster. So what we have to do is to take these 2 probabilities. We want to know the probability of a roller coaster that she chose and a random roller coaster choice. And remember what and means? So 2/5 for the first one, 2 out of 5, and then 1 out of 4 for the second one. And again, I would encourage you to use your calculator, because if you use just general math, you would get 2 over 20. But your calculator is going to go ahead and simplify that for you. So 2 over 5 times 1 over 4 equals 1 over 10. So the probability of this happening is 1 out of 10 chances. Now, you can get your percent if you need it by doing 1 divided by 10, and that'll give you this decimal. You add your 0, because percents always have 2 places, and that's a 10% chance of this occurring. Okay, number 5. I'm going to use a tree diagram of this one also. Again, there are other ways to do this, but I like this one to show you the tree. So let me get some space and let's read the problem. If you roll 2 number cubes 30 times, how many times is it likely that the sum of the 2 cubes will be a 7? Well, I'm going to worry about that 30 times in just a minute. The first thing I'm going to do is to look at my 2 number cubes. So let's say that, oops, I thought I had a square still on there. I'll draw one. So here is one side of my number cube, one face, and let's suppose that it's a 1. Actually, let me do this. I'm being lazy today. Let's make all 6 sides. There are 3 of them. Let's go here 4. And I know we're rolling 2 of them, but I'm not going to draw that many. That would take me all day. Even cheating or with the shortcut, it would take me all day. Okay, so here's the first one. That is a 1. And then another side of that one is a 2, a 3, a 4. This is all one die. I'm just stretching it out so we can see all the faces. So this is the first die. Now remember, we're rolling 2 of them. So if this is the first one, first die, what could happen on the second die? Because it looks just like the first one. And I'm 1 short, so let me squeeze him in right there. So on the second die, you could get the 1, just like this, the 2, the 3, the 4, the 5, or the 6. So on the second die, you could get any of these numbers paired up with that 1 on the first die. So you could roll a 1 and a 1. You could roll a 1 and a 2. You could roll a 1 and a 3, a 1 and a 4, a 1 and a 5, or a 1 and a 6. Those are the possibilities. Do any of those add up to 7? Yes, the 1 and the 6. So this pair right here add up to 7. Okay, so what if on the first die you got a 2? That's definitely possible. So you roll the second one, and what are your possibilities? Tree diagrams show you possibilities. Well, we could have a 1, a 2, a 3, a 4, a 5, or a 6. Do any of these add up to 7? There's the first die. Here's the second die. 2 plus 5. So this pair adds up to 7. Okay, I'm seeing a little bit of a pattern here. So let's look at this example. If the first die gives me a 3, what are my possibilities? And if this is getting on your nerves, you can fast forward. But if you need to see all of this, I'm going to go ahead and finish it. Because this, if you're not completely with me, this will help. Okay, so on the second roll, I could get a 1, a 2, a 3, a 4, a 5, and a 6. And do any of those add up to 7? Well, 3 and, not that one, 4 do add up to 7. So each one of these has a possibility of giving me a 7. And I'm going to move my set of these over. Okay, so let me zoom in. We'll keep going. Again, you can fast forward if this is getting on your nerves. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And I have a 4 plus a 3. There's the one that would give me 7. 1, 2, 3, 4, 5, 6. You get the drill. 1, 2, 3, 4, 5, 6. 5 plus 2 is 7. Whoa, sorry. And then finally on this last one, 1, 2, 3, 4, 5, 6. So if the first die gives me 6, what would I need on the second roll to make the 7? Well, 6 plus 1 is 7. So rolling the number cubes, or the dice, this way, how many possibilities are there for getting a 7? If there's one possibility for each of these, that would be 6 possibilities. Okay? So highlighting them helps you to see the 6 possibilities. So let me think about how I'm doing this. I'll tell you what, let me just do it down here. So the probability of getting a sum of 7, here's the tricky part. The sum of 7, there are 6 ways that can happen. We've highlighted them there in blue. Those are the 6 ways to get the sum of 7. How many possibles are there? So you have to count all your branches on your tree. The first one, this one, has 6 branches, 6 branches, 6 branches, 6, 6, and 6. So 6 times 6 is 36 branches, or 36 ways. Of the 36, only 6 of them are what we want. But there are 6 out of 36. And then we're going to times 30. Remember the 30 times? So the math problem that you want to do is the fraction 6/36 times 30. I would use my calculator because this will definitely simplify. And the answer you're looking for is 5. On 5 rolls out of the 30, I would expect to get a sum of 7. That is not an easy problem. It really isn't. Okay, one more, and I think it's a short one, so I'll just plug it in right here. A survey of 50 people asked which was their primary way of accessing the internet. 15 people said their smartphone, and I'm just going to make a frequency table. 25 people said a laptop. 8 people said a desktop computer. And 2 people said they didn't use the internet. So the first thing I want to make sure of is that adds up to 50. And it does. So there are 50 people that we surveyed, that we asked. Okay. What is the probability that a randomly chosen person uses a smartphone as their primary access to the internet? Well, the smartphone is, out of 50, the smartphone is 15. But that's going to simplify. If you put that in your calculator as a fraction and press equals, it will give you 3/10. And if you want that as a decimal, do 3 divided by 10, you'll get 0.3. And you can turn that into a percent by moving your decimal 2 places. So the probability is this, 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 or this. Any of those could be an answer on a multiple choice test. So it's important that you know how to find all of those different forms. Okay, I hope you did well on this exam. And that brings us to the end of the course. So there is a final exam that covers a lot of things on one test. If you want to take that, it's coming up next, and there will be a video to explain that also. So I'll see you soon. Have a great day.